Hi guys, welcome to our video lesson in which we're going to be finding zeros of polynomial functions, and then we're going to start talking about what the multiplicity of a zero means and how that affects the behavior of the graph at the zero values. So our first learning target is, I can find the zeros of a polynomial function in intercept form. So recall that the zeros of a function give the graph's x-intercepts. Okay, remember x-intercepts are where our graph crosses the x-axis. Remember, zeros are the x values that make f of x or y equals 0. So that's why those values do give us the x-intercepts on the graph. So finding the zeros of a polynomial function is easiest when the function is in intercept form. So intercept form, we've actually looked at before. Another word for it that we may be used to is factored form. So we've been talking about standard form quite a bit, and standard form is when it's all multiplied out and we just have single monomials added together. Well, factored form or intercept form is when we have factors in parentheses with x variables in them being multiplied together. And when we are given a function in intercept form or factored form, to find the zeros, all we need to do is set each factor equal to 0 and solve. So we've done this, for instance, when we were solving quadratics by factoring, that's how we solved them. We would factor them and set each factor equal to 0. So here is the intercept form of a polynomial function. As I was mentioning, sometimes we might have an a value out front other than just 1. And so that's just a number. Otherwise, all of the factors must have a variable, meaning your x, and then each factor is subtracting a constant. So these would all be numbers. So if you look down here in our example 6, all of these are intercept form. So you can see the factors there. Okay, so we are going to find the zeros from each of these. Remember, to find the zeros, all we need to do is set each factor equal to 0 and solve. So in letter A, I have f of x equals x times x plus 3 times x minus 1. I actually have 3 factors here because x itself is a factor. So if I would set each of these factors equal to 0 and solve each of these little equations, I would get my 0 values. Actually, x equals 0 is 1 right away. For the next one, I would subtract 3, so I have x equals negative 3. And the last one, add 1, and I have x equals 1. Okay, so there we go. As you can see, we've done this before. So sometimes you might not actually need to write out those little equations, but it's totally up to you. Let's look at B. I have f of x equals the quantity x minus 4 squared times x plus 1 times x minus 1. So actually here I do have 4 factors. This x minus 4 quantity squared just means that I have 2 of these factors. Okay, so regardless, if I set each of those equal to 0 separately, I'm still going to get positive 4 for those. But I do want to make note that this is squared because we're going to be talking about what that means in terms of the graph. From this factor x plus 1, I will get the 0 value of negative 1. And from this value x minus 1, I will get the 0 value of positive 1. All right, moving on to C, I have f of x equals the quantity x minus 2 squared, and then x minus 6. So again, this one is squared, which we'll talk about in a little bit, but the factor is just plain x minus 2. So what would make that equal 0? It would be positive 2. And then the factor x minus 6, I would have the 0 value positive 6. And finally, for letter D, I have p of x equals x times the quantity x plus 5 cubed. So essentially, I have 3 of those. So my first factor is just x, and when we have x, that's just 0 for our 0 value. And my second factor, x plus 5, will give me this 0 value of negative 5. Alrighty, moving on. So I'm just going to start doing maybe one or two examples in the next part of our notes to see what exactly happens on the graph when we do have these exponents like 3 and 2 on a factor, which means what happens when a factor shows up more than once. So it says investigating the behavior of the graph of a polynomial function at its zero values. Notice that some of the factors in the functions above had exponents other than 1, meaning they occur more than once. The number of times a factor occurs is called its multiplicity. Okay, so let's see how the multiplicity of a factor affects its behavior of the graph at its related x-intercept. So we're going to graph each of these functions on our graphing calculator and then sketch them below and see what happens. So in letter A, these are the same functions as we found the zeros of up here, so I'm just going to rewrite them. So for letter A, we found that the zeros were 0, -3, and +1. Okay, so remember, our zeros give us our x-intercept. So we know that there's a point on the graph at 0, 0, -3, 0, and 1, 0. Those are our x-intercepts, where the graph crosses the x-axis. Well, let's see what this looks like when I graph it on my graphing calculator. So if you have your graphing calculator at home, you should pull it out and graph this with me. Okay, so I'm going to go to my y equals, and I'm going to type x times x plus 3 times x minus 1. And I'm just going to press zoom 6 to look at a standard window. Whoop, that was fast. Okay, so as we can see, our graph is crossing. There's an x-intercept there at 0, 0. We also have the one over here. We knew what happened at 1, 0. And then all the way over on the left side, sorry, I can't really get over there very quickly. Our other x-intercept we knew was going to be at -3, 0 over there. So we see it just kind of curving through. So let's draw that on our notes. So what was happening is it was coming up, going through -3, coming back down, and coming back up. So really try to go through your x-intercept. Sorry, it's kind of hard on my computer. There we go. So basically we see that on this graph, it's just going through those values. All right, so graph crosses the x-axis at each 0 value. Okay, cool. Let's look at B. F of x equals the quantity x minus 4 squared times x plus 1 times x minus 1. So what we noticed is we had this factor x minus 4 and we had the 0 value of +4. But because that is squared, it has a multiplicity of 2. You can also call that a double 0, okay? Then we have the single zeros of -1 and +1. So we know the graph is going to touch the x-axis at +4, -1, and +1. And we are going to graph this function on our calculator and see what it looks like. Okay, back to my calculator. Go to my y equals and clear out my y1, and I'm going to type the quantity x minus 4 quantity squared times x plus 1 times x minus 1, and graph. Woo! That looks crazy. But the big thing is I can see what's happening at my x values. At x equals -1, looks like my graph is going through it. At x equals +1, it's going through it. But looking at x equals 4, it's bouncing off of it much like a parabola would look. If I change my y values, I'm going to make them lower and higher just so we can see them. There you go. You can see what this graph looks like a little better. All right, so here we go. Let's graph it quickly, and then we will talk about this tomorrow. So it was coming down through here, and then it was bouncing off at 4. So what we can see is at the double 0, it's bouncing. Okay, we'll talk more about this tomorrow in class. Bye, guys.